Shall we? So, we talked a little bit about work yesterday. Force times the distance an object is moved. Let me ask you a couple of questions. If I pick up, we'll do this partly on camera. If I pick up this bottle of glue.
Oh, clever, in the video.
It's in the video.
Whoa.
If I pick up that bottle of glue, I am doing work on the glue, correct?
Correct.
Okay. If I'm picking this up at constant velocity, the work is, the force that I'm exerting is equal but opposite to what? Force of gravity, yeah, mass times g. Okay. Now, if I pick up this glue and I hold it here and then I walk across the room with it, am I doing any work on the glue?
Yeah.
No, I'm not. No, I'm not. Go with your first instincts. I'm not. Why not?
Because you're moving.
Because science. Oh, you're moving.
Because science.
Because science.
Good job.
Okay, I've picked it. Here, I'll even get on camera for this.
Whoa.
I've picked it up. I'm walking this way with it.
No, because you're
The force that I'm exerting to move across the floor
you're
is not in the same direction as the motion of the glue. So you pick up a cement block and walk across this room with it. You did work when you picked it up. You walk across the floor with it, you're not doing work on the block anymore. That's tricky but important. Okay? Your whole life is a lie, that's right. Now, when you pick up the block and walk across the floor with it,
on video.
yeah. When you do that, you're doing work on the U and block system. Because you and the block are connected, you're holding the block. But at that point, the force you're exerting is not in the same direction as the motion of the block, therefore you're not doing any work on the block itself.
What if you have a block and you jump?
Then you're doing work on the block. Because the force you're exerting is in the same direction as the motion of the block.
Alright.
If you take the block and you shove it, you're doing work on the block. The force you're exerting is in the same direction as the motion of the block.
If you just push the block along the ground,
You're doing work on the block.
but if you pick it up and walk, then you're not doing
Then you're not doing work on the block.
What about you doing?
You're holding it,
Okay, what if you're walking
Right.
and while you're still lifting?
then you're doing work on the block, but only in the up and down direction, only on the y-axis.
It's just on the block.
Yeah,
Yeah, because you're holding it.
you're holding it.
Okay.
Now, if you're moving the block and shoving it, we can look at 5 different axes and 4 different forces. But there's an important distinction there in picking it up versus picking it up and walking with it. And you'll, spoiler alert, you'll have some problems like that. So, okay, now let's talk about kinetic energy. What do you remember about kinetic energy? That's not on the notes. Close your eyes and tell me what you remember.
Moving.
Okay, energy and kinetics, energy and motion. Some of you could accurately be described as hyperkinetic. Not that I'm making eye contact with anybody. Okay, fine. Fine, you're hyperkinetic. Hyperkinetic means somebody who is in constant motion. Can you think of a more apt description? Someone who is hyperkinetic is in constant motion. Kinetics is the study of motion. So kinetic energy is energy in motion. And do you remember anything about kinetic energy from physical science? It's been a long time.
When you push something, like it had, I don't know why, but I remember when like a car's at the top of a hill,
Okay.
it's got potential, but then when it starts going down, it's got kinetic.
Good. Okay, that's an
That's all I
excellent thing to remember
remember.
because we're going to talk about both potential and kinetic today.
I remember that.
Okay, but of course we're going to step it up a notch from what you did in physical science.
Oh,
So,
yeah,
No.
that was so nice.
you know these things. Energy is related to work because energy means you have the ability to do work. Work is related to force because work is done when a force is exerted and something moves. So you know these things are connected. Now let's do the math to connect the dots. Okay, let's talk about a couple equations. Our old friend F equals ma.
My note card's filling up quick.
Yep. F is equal to, force is equal to mass times acceleration, and work is equal to force times displacement, delta x. So we can rearrange those and we get work is equal to mass times acceleration times displacement, or WMAX. Okay? Now, if if we go back to kinematics, chapter 2, we're pulling this all together. We're weaving a carpet here. It's a beautiful thread. Final velocity is equal to final velocity squared is equal to initial velocity squared plus 2 times a displacement. We can take that a delta x, rearrange to get that. We now have vf squared minus vi squared divided by 2 equals a delta x. Well, we have an expression for a delta x. We can plug that into w equals ma delta x. Oh boy, we'll do this all by hand on the board, I promise. Rearrange it, what we get in the end is that work is equal to 1/2 mass times final velocity squared minus 1/2 mass initial velocity squared. Does that sound fun? Okay. You're going to need that one. That's going to go in your note card. You're going to use that a lot. So, let's move on to the sample problem, shall we? Yes, sir. Can I go back? I can go back. Okay. We'll move on to the sample